We can think of Western Europe's post-glacial genetic history as a series of several big migrations. Put simplistically, first came the Western hunter-gatherers who settled in the west of the continent around 15,000 years ago. Then, beginning around 7000 BCE, farmers from the Fertile Crescent spread across Europe, bringing agriculture with them and mixing with the local hunter-gatherer populations. Thousands of years later, around 3000 BCE, another major migration arrived from the Eurasian steppe, transforming the genetic landscape of much of Western Europe once again. But one place seems to have largely escaped this third wave of migration. The Mediterranean island of Sardinia has a rather unique position in this story of European prehistory. Whilst populations across the continent were being essentially replaced by incoming steppe ancestry, Sardinia appears to have remained remarkably isolated from such changes. This is strange because during the Bronze Age, the island underwent massive cultural changes. This was the time of the Nuragic culture, famous for its thousands of huge stone towers, its giants' graves, and its holy wells. Yet despite these extraordinary cultural developments, the people themselves seem to have remained largely the same. How could an island experience such social and technological change without a major influx of new groups? And just how isolated was Sardinia from the rest of Europe, and for how long? An ancient DNA study that came out a few years ago offered new insight into this research by analysing the genomes of people who lived on the island at different times, covering a period of several thousand years. Let's take a look. Let's start with a very succinct, but for context, necessary overview of Sardinian history. If you want to get straight to the DNA study, skip ahead using the chapter titles in the description. Sardinia sits in the middle of the Western Mediterranean between mainland Italy, Spain, and North Africa. Its geographic location makes it look like it must have been an integral part of ancient trade routes, migrations, and invasions. At the very least, we would expect it to have followed a similar trajectory to the rest of Western Europe with regards to the genetic population replacements that took place during the Neolithic and the Bronze Age. The archaeological record tells us that Sardinia's first farming communities arrived around 6000 BCE. These early settlers brought agricultural techniques and domesticated animals, gradually replacing a hunter-gatherer way of life, just as they did all over Europe. Over the following millennia, Sardinia developed its own distinctive cultures, whilst remaining connected to maritime networks linking mainland Italy, southern France, and Iberia. Its elaborate rock-cut tombs known as Domus Trajanus, and many of its menhirs belong to this Neolithic period. Sardinia is one of the main sources of obsidian in the Mediterranean, and a lot of obsidian tools found at Neolithic sites across Europe can be traced back to its extinct volcanic complex at Monte Arci. That's just one indicator of Sardinia's important position within Neolithic Europe. During the Copper Age and early Bronze Age, Sardinian communities became increasingly organized and quite prosperous. Around 1600 BCE, a unique culture emerged, the Nuragic culture, named after the thousands of stone towers known as Nuraghi, many of which still cover the island. The Nuragic people created a remarkable, but in some way still mysterious Bronze Age society. We still don't know the purpose of their massive stone towers, but they likely played a defensive role. They also developed advanced bronzeworking skills and established trade links with Mycenaean Greece, Cyprus, and the Levant. For centuries, Nuragic Sardinia flourished as an important center of trade and metallurgy. Beginning in the first millennium BCE, Sardinia became more deeply integrated into the wider Mediterranean world. Phoenician traders established coastal settlements there, followed by the expansion of Carthaginian influence from North Africa. These newcomers introduced new technologies, religious practices, and economic connections. In 238 BCE, after the First Punic War, Sardinia came under Roman control. For nearly 7 centuries, it formed part of the Roman world. Roads, towns, agriculture, and trade expanded, while Latin language and Roman customs gradually spread across the island, yet many inland regions retained strong local traditions and a degree of independence from direct Roman influence. Following the fall of the Western Roman Empire in the 5th century, Sardinia experienced a period of political uncertainty, including Vandal and later Byzantine rule. Over time, the island developed a distinctive system of independent states known as the Judicates. Between the 9th and 13th centuries, these kingdoms governed much of Sardinia while balancing relations with powerful maritime republics such as Pisa and Genoa. By the 14th century, the Crown of Aragon began conquering the island, bringing Sardinia into its expanding sphere. Despite periods of resistance and conflict, Aragonese authority gradually strengthened. By 1500, Sardinia had become a strategic possession within the Western Mediterranean, shaped by thousands of years of trade, conquest, and cultural exchange. It's this long time period between the Neolithic and this date of 1500 that the DNA samples in the study belong, which is why I wanted to give a quick overview of the various changes that happened on the island over those millennia. So what does the genetic research tell us? Before I start, so that you can understand the diagrams, EEF means Early European Farmer Ancestry and is associated with the Neolithic expansion of agriculture from the Fertile Crescent. WHG means Western Hunter-Gatherers, so is associated with the Paleolithic and Mesolithic inhabitants of Western Europe. And steppe refers to the Eurasian steppe ancestry that arrived in Europe during the Bronze Age migrations. The paper I'm talking about was published in the journal Nature Communications in 2020 and was the first study to analyse genome-wide autosomal data from Sardinia. It looked at the skeletal remains of 70 individuals that were radiocarbon dated to between 4100 BCE and 1500. These individuals obviously covered a huge span of history. By comparing these ancient genomes with hundreds of ancient and modern populations across Europe, North Africa, and the Near East, the researchers were able to determine how Sardinia's population changed over time. The team found that the DNA of Sardinia's middle and late Neolithic individuals showed a strong connection to Neolithic farming populations from the Western Mediterranean, especially groups from southern France and Iberia. A more detailed analysis of Y haplogroups supported a substantial westwards gene flow during the Neolithic that spread along the Mediterranean coast of southern Europe. However, since early Neolithic data was not available, the exact timing of this gene flow entering Sardinia couldn't be determined. Although much of the rest of Europe experienced substantial gene flow from the Eurasian steppe starting in around 3000 BCE, there was no DNA evidence for this in Sardinia. It's especially telling that a particular Y haplogroup associated with expansions that brought steppe ancestry to Britain and Iberia was completely absent from the Sardinian sample. This means that during the Bronze Age, Sardinia was isolated from the gene flow events that took place on the European mainland. Of course, it's still possible that admixture with genetically similar populations did occur. The archaeological record shows that during the Bronze Age, Sardinia was a part of vast trade networks, so it was not isolated in that respect. But it's quite strange that Sardinia appears to have experienced genetic continuity at a time when its culture underwent a massive transformation. Often such cultural changes are also associated with genetic changes. This genetic stability lasted for around 2000 years. After the Nuragic period, Sardinia's genetic isolation changed. DNA from individuals buried at the Phoenician Punic sites of Monte Sirai and Villamar reveals the arrival of ancestry from the Eastern Mediterranean, while some individuals from Villamar also show evidence of North African ancestry. By the medieval period, samples from the San Nicola necropolis indicate an additional influx of ancestry from the northern Mediterranean. Despite these new genetic influences, the incoming populations carried relatively little steppe ancestry compared to much of mainland Europe. As a result, modern Sardinians have retained an exceptionally high proportion of early modern farmer ancestry, making them one of the closest living genetic links to Europe's first agricultural populations. Interestingly, another European population known for its high levels of early European farmer ancestry is the Basque people. For years, researchers have speculated that Sardinians and Basques may share a deeper genetic connection rooted in Europe's Neolithic past. This study found evidence consistent with that idea, detecting a similar genetic signal in both populations and suggesting that each preserved an unusually large share of ancestry from the continent's earliest farmers. It's very interesting that genetic continuity characterizes the transition from the Neolithic to the Bronze Age and encompasses the time of the Nuragic culture. Extensive trade networks existed across the Mediterranean at that time, and the Nuragic culture was certainly a part of them. Many artifacts excavated from Nuragic contexts in Sardinia suggest contacts with and influences from the Mycenaean Greeks, Cyprus, and the Levant, as I said earlier. But the DNA shows that despite these interactions, large-scale population replacement did not occur. Trade networks were active, ideas were exchanged, goods moved across the sea, yet the genetic makeup of Sardinia remained remarkably stable. The Nuragic population appears to have been largely descended from the island's earlier Neolithic inhabitants. This shows that cultural exchange does not always imply major migration. People can adopt technologies, styles, and ideas without experiencing large-scale genetic turnover, even if the latter is found more commonly. What I like about these ancient DNA studies is that along with ruins, pottery, tools, and visible elements of material culture, they teach so much about the people who lived in a particular place. Not only do we learn about ancient migratory patterns, but we also find out about kinship and the roles people played within their family groups. In the absence of a time machine, modern science might not be able to tell us everything about our ancestors, but it's giving us more and more information the more that technologies in this space develop. I still wonder though, where did the Nuragic culture get their ideas from, especially for those rather grand circular towers? I visited several myself, and many of them evolved to be pretty big complexes over time. I see a combination of influences from their wider trade network. But what do you think? Let me know in the comments. Thank you for watching, and I'll see you next time.